8.4. This is the last section of Chapter 8. We're talking proportionality theorems. Proportionality theorems. Right down here, we are going to construct a triangle where two sides are parallel. And that one parallel side is kind of inside our triangle. So I went ahead and I did that right here. Kind of a mess, but we'll figure it out. So these two sides here, these are parallel. And it's asking us to compare the ratios of, so down here it says compare the ratios of AD to BD. So what we're going to do is we're going to take AD and put it over BD. We're going to set that equal to AE over CE. Okay, we're going to see what we get. So right here, let's find the lengths. Should have it here. We have 6.21 and we have 2.51. So we're going to say 6.21 over 2.51. I'm going to set that equal 6.15 over 2.49. Okay. If you type these into your calculator, I type these into my calculator, you get 6.21 divided by 2.51. That should be 2.47. And 6.51 divided by 2.49. Oh, sorry, 6.15. Divided by 2.49, it's 2.47. Okay, so these are equal. They are proportional. Okay, these side lengths are proportional. What's it say here? Compare the ratios. What's it say down below? Write a conjecture to summarize the results. When we have two parallel sides, we know that we have proportional side lengths. Okay, that's what we know. That's what we have. What's going on here? It says bisect angle B and plot point D. Okay, so we're going to plot this point here, right where that angle bisected, right? So we have two equal angles. This goes right through those two angles, and then I put a point where that intersects AC. That's what it asks us to do. Then it says compare the ratios of AD to DC and BA to BC. So I went ahead, I'm going to exit that one out, leave there, we want this one. Okay, so I went ahead and made this triangle. This angle here, that's bisected, so we have two equal angles. And now I want to find the lengths of these sides. Okay, well, where's the distance here? Scroll down a tad, there we go. So we have, come on now. Okay, I thought I did this. I think I did. It's just being irritating. And I want to find the distance of that. Okay, this isn't working, which is frustrating. I want the distance of J. Okay, we have 3.41. We have 4.41. 1.7. Finally, thank you. Okay, I'm gonna hide some things here. We're gonna hide this because that's gross. We're gonna hide this. Okay, we can't hide it, I guess. So we have 4.42. We'll say 4.42 over 3.42. And this next distance should be just fine. The distance of h is that. The distance of g is that. So we have 6.21 over 4.81. Now let's divide these. We have 1.29, and we have 1.29. Okay, again, these are proportional. So when we have an angle that bisects an angle on the triangle and goes through the opposite side, we know that we have a proportional side lengths. Number 3, what proportionality relationships exist in a triangle intersected by an angle bisector or a line parallel to one of the sides? We just went through that. Okay, I'm not going to write a long definition for you. We just went through that. We just discovered it. Number 4 says use a figure on the right to write a proportion. So we have two parallel sides. We have a parallel side here, a parallel side there. And we know that the sides, so AD over DB, so AD over DB is going to be equal to our other side lengths, BE and EC. So, well, I have to say, if I said AD, well, that bigger side first has to be EC or CE on top over EB. Okay. So they're proportional. They have proportional sides. Corresponding angles, ratio, proportion. You guys should know all of those definitions. I'm not going to write them down. If you'd like to look them up, you can. I'm going to talk about these theorems. If a line parallel to one side of the triangle intersects the other two sides, then it divides the two sides proportionally. Okay, so that's what happens when we have two parallel sides. So, for example, we have if TU is parallel to QS, then RT over TQ, RT over TQ is equal to RU over US. Here we have the converse set. So if we have proportional sides, so if RT over TQ is equal to RU over US, then we have parallel sides. Okay, so if they give us those proportions, they're equal, then we have parallel sides. 3 parallel lines theorem. If 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. So if we have 2 transversals, UW, so UW over WY is equal to VX over XZ. And they're proportional. So for example, if this was 5, this was 7, this was, oh, this is actually going to be 5, this is going to be 7 as well. Okay. That's a bad example. We'll get through it. We'll get some more examples here in a minute. Angle bisector. If a ray bisects an angle, of a triangle, then it divides the opposite side into segments whose lengths are proportional. Okay, so they're not equal, but they're proportional. So AB over DB is equal to CA over CB. Let's get into some extra practice here. Find the lengths of AB. So here we have, we know that 5 over 10, using our parallel lines theorem that we just learned above, is equal to AB over 6. Cross multiply, we get 30 is equal to 10 times AB. Divide by 10, we get 3 is equal to AB. Over here, same type of thing. We know that 2 over 9 is equal to AB over 7. Cross multiply, we get 14 is equal to 9AB. We know that AB is equal to 14 over 9. Number 3, determine whether they're parallel. Okay, so we're going to determine if these side lengths are proportional. So we know that 3 over 4 has to be equal to 4 over 5. If we cross multiply, we get 15 is equal to 16. Are those proportional? No, that's not equal. So these are, so AB is not parallel to XY. Not parallel. This next one, again, just find the ratios. 6 over 4 is equal to 7.5 over 5. Cross multiply, we get 30 is equal to 4 times 30. So here, yeah, AB is parallel to XY. Moving on. We're just going to use this diagram to complete 5, 6, and 7. So UV over UW, UV over UW equals XY over, what's it going to be? It's going to be XZ. Number 6, XY, find X and Y, right here. XY over YZ is equal to blank over VW, it's going to be UV. Number 7, blank over ZY, blank over ZY is equal to WU over WV. So what is, it's going to be ZX. Number 8, 9, find the value of the variable. So we're going to use proportion. We know that X over 5 is equal to 9 over 15. Cross multiply, we have 15x is equal to 45. Divide by 15, x is equal to 3. And this whole thing is 14 on the bottom. don't know if it's equal. Okay, but we know that this is b. We know that this is b minus 14. Okay, so if I were to write this ratio, we'd have b minus 14 over b is equal to 6.75 over 9. Cross multiply, we have 6.75b is equal to 9b minus 14 times 9, which is 126. Subtract 9b, so 6.75 minus 9, that's negative 2.25, negative 126, and divide negative 126 by negative 2.25, and you'll get your answer B, which is 56. Okay, and that is okay. Looking at this a little closer, we made a little bit of a mistake. Is this b minus 14? No, and you might have caught that, which is it's great. Thank you for catching it. Sorry you couldn't correct me in class. This is actually 14 minus b. And it makes a world of difference. 14 minus b. If I change that, 14 minus b over b. Can I cross multiply? I'm going to have negative 9b, and I'm going to have a positive 126. So it's going to be positive. This number here changes. So I'm going to add 9b to 6.75. This answer we can get rid of. Sorry about that. 6.75 plus 9, that's going to be 15.75b is equal to positive 126. Divide by that, we should get b is equal to 8. Hey, my apologies, I did make a mistake. And it's okay to make mistakes. That means you'll learn from it, right?